This is another question from the sprint round talking about this weird function phi and its properties, right? So for real numbers a and b, let a phi b be 3a squared minus b squared. Given that n is a positive integer, what is the minimum possible value of 4 phi, 5 phi n, all phi by 2? So this seems like a monster of a thing, but we probably can start working on it from the inside out and try to build up some idea of what's going on, right? So we can simplify this 5 phi n thing by just taking 5, plugging it in for a, and taking n and plugging it in for b. So this 5 phi n, I guess, so this entire expression becomes 4 phi 5 phi n, which we said was 3 times 5 squared, which is 25. So 3 times 25 is, what, 75? Then minus n squared, and then all of that feed by 2. Now we can do this again. We can feed again by plugging in 4 for a, and then 75 minus n squared for b. And we get 3 times 16, so 48, minus 75 minus n squared, all squared, and then that's feed by 2. And what we can notice here is, if we do this again, we're just going to end up with this expression squared minus 2, right? So what we can do is, what we notice is n is only really in this side, and it's always going to be this function of n, and it looks like this function of n is going to end up on the left side subtracted by some constant 4. So what we really can do here is, if we want to find the minimum possible value of this weird expression, which looks like it's just going to be some expression with some polynomial of n squared a bunch of times, is we can just focus on minimizing this inside expression, and then we can reason about the results. To minimize this expression, we can just set it equal to 0 and then find what integers, positive integers n, will give us closest to that 0 value. So we can take 48 minus 75 minus n squared, all squared, equals 0. And we can move this over and perform some algebra. We get 75 minus n squared is equal to square root of 48, which is 4 square root of 3. So we get n squared is equal to 75 minus 4 square root of 3. So this just says that n is most likely between, 75 minus 4 and a little bit over 1. That's going to be between n equals 8 and n equals 9. So between 64 and 81, right? So now let's plug these in and see which one of these minimizes this function the most. We plug in 8, we get 75 minus 64, which is 9. 9 squared is 81. Yeah, 9 squared is 81. So that'll give us negative 73. So that's pretty small. And then n equals 9. We plug, but that's still pretty large because we're going to end up squaring this. So it's going to end up being something positive, right? We'd get negative 73. That'd be really large. If we plug in 9, we get minus 81. The 75 minus 81 term becomes 6. 48 minus 36 is only 12. So that's much smaller, right? And we can sort of just write this down as a little note for later. 48 minus 75 minus n squared is minimized. N squared is minimized when n equals 9. All right. So now the last step is just to plug in values here and finish up the problem. So if we're phiing this, we said that 48 minus 75 minus n squared, this became 48 minus 75 minus 81 squared. So that became 48 minus, 36, which is 12. So this entire inner expression is just 12, and we just need to evaluate what's 12 phi 2. So then 3 times 12 squared is that minus 4. So we get 3 times 144, which is 432, minus 4 equals 428. So the answer to this question was 428.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.